start? We are live? Okay. Oh yeah, the dress code.
Yeah, dress code.
Here we are. Yeah. So welcome to this session on FN project. So before I start some logistic, so this was me nearly a year ago in a conference in Sweden, and someone said that it's not a real conference unless you read Oracle Safe Harbor statement at least once. So please enjoy. Having said that, today I will discuss about FN project, which is an open source project, and it will be at some point in time the basis of our serverless offering. I mean the commercial offering from Oracle for serverless or function as a services. Today we just have the project, the open source project, so there is no product, there is nothing to buy, so we're on the safe side. Another disclaimer. Despite my French accent, I'm not French. I live in Belgium, where quite some time ago I was working for a telco on Java-related project. After that, I joined Sun, where I spent 10 years working again on Java-related project. And at some point in time, I obviously joined Oracle. So basically, I've been doing Java for the last 20 years. The interesting thing is that you see this NC card there. It's network computer. Anyone knows what NCI is? So NCI was basically an Oracle spin-off. So I used to work with NCI back in, I think, 96 or 97. So that was my first contact with Oracle. But obviously now, I'm really in touch with Oracle on a daily basis. So let's discuss about FN project. So as I told you, FN project will be the base of our function as a services platform. And whenever you talk about serverless, there is always that naming question. So obviously, serverless name is not a very good name. I mean, naming is very difficult. So there is this very famous blog post that said, we could have called it Jeff. It doesn't necessarily mean anything. The idea with serverless is that at the end of the day, what we're talking about function. We're talking about code that you as a developer will ship to a FaaS platform. So that's really what we are focused on. Obviously, to run that code, there are a bunch of servers. There are proxy, there are firewalls, and so on and so on. But you as a user of that FaaS platform, it's not something that you have to take care of. It's not something that you have to manage. It's really something that should be fully handled by the FaaS provider. And to talk about, well, just to give an example that naming is sometimes difficult. So the project name FN. FN stands for function. But there are clearly some markets where FN is not necessarily the best name. And those are the French markets. So to give you an example, FN in France stands for Front National, which is the extreme right populist party. So it's not something that is, well, I mean, clearly in France, as soon as you do FN, people tend to think about Front National. In Belgium, it's not better, because if FN in Belgium is, let's see, FN America. FN stands for Fabrique Nationale, which is basically, that's their slogan. The world's most battle-proven firearms. So it's not even battle-tested, it's battle-proven. So again, anyway, it only applies for the French-speaking side of the world. So today we're going to discuss about Project FN, and just to set the stage, if you look at, I mean, if you want to be serious with the technology or an architecture, you need to have a manifesto. And obviously, serverless, there is a manifesto. There is a serverless manifesto. I'm not going to discuss about all the core idea behind the manifesto, but I just want to highlight a few. So, what is serverless? So, at the heart of serverless, we have this notion of a function. A function is basically a well-bounded piece of code that most of the time has an input, most of the time has an output, and that function will do something. It has one job, and it should obviously do that job very well. So that's really the idea between serverless. We have this idea of well-bounded piece of code, function, that should perform something. Now, function, you should not necessarily take the function as as in functional programming, or as in a mathematical function. A function can have some side effect. So for example, if your function doesn't have any output, ideally it should have a side effect. So that's really one of the core ideas we have between this serverless notion. So we have function. Obviously, we need to have code that basically represent the function. So you as a developer, it's really what you will focus on, writing the function. So ideally, you will just focus on plain whole code. So the underlying serverless platform shouldn't be exposed through your code. So that means that you will just write plain code, regardless of the fact that at the end of the day, it will run on a serverless platform. So ideally, the underlying infrastructure should not be exposed. So there should be any specific API that basically you would use to do something specific. You just want to ship some piece of code, and that's it. Obviously, the underlying infrastructure has to deal with load balancing, failover, all those kind of things. But again, you as a developer will just focus on code, right? Now, serverless, obviously, there are a bunch of economical impact. So ideally, you will just pay when your function is running. That's one of the core ideas of serverless. So if your code is idle, you will not pay. So that means that you can't do over provisioning, for example. If your function is not used, it will not cost a cent. Obviously, if your functions are largely used, it will cost you. Now, serverless also give the ability to have a more granular approach. So you have those functions that will run on the top of a platform, and that's something that can be used by the platform provider to basically increase the density. Increase the density to reduce cost. And obviously, at the end of the day, the cost reduction that the service provider is able to do should also be reflected on what you're going to pay. Fault tolerance. So when you will run your function on a platform, again, you don't necessarily know what's behind that platform. So that means that your function is not attached to any specific server. So you will not deploy your function on a specific server. You will deploy the function on the platform. And it's up to the platform provider to basically make sure that your function is running when it is invoked. So the fact that the function is not attached to a specific server allows basically to increase the availability of your function. So today I'm going to discuss about FN Project. So we have a very long slogan as well. So FN Project is an open source container native polyglot FaaS platform. So it's container native, so that means that under the hood we are using containers, Dockers. It's something that here you will be exposed to because I will basically show you how it works. But at the end of the day, if you are using the platform, it's not something that you necessarily need to know that we are using containers under the hood. It's polyglot, so you'll see that we are supporting different language. So you can write Java to write your function, or you can basically use any language well, a lot of language you will see. It's a FaaS platform, obviously, so it's a function as a service platform. Yeah, and it's open source. And it might be useful to spend like 1 minute on open source, because most of the time when we are using in the sentences Oracle and open source, people tend to ask questions. It's really open source. By that I mean that today we have the open source project that will be used for our commercial offering, our FaaS platform offering at some point in time. So it's not like it was mentioned yesterday, where we basically have done everything internally, and then when the commercial service is ready, we open source the code. It's really opposite. We start outside of the firewall, and when it's ready, we will have an offering based on that. We are using the Apache v2 license. The governance is based on the CNCF governance. It's basically the Prometheus governance. So github.com/fnproject, and you will basically see all the code. It's not an open core where what we have on our GitHub repos is just a subset of what we will use in our offering. It's really everything is there. So I will show you how it works, but before I do so, we need to understand a few of the basic concepts. So we have this notion of FN server. So again, at the end of the day, if you're using the platform, it's not something that you will necessarily need to know. But for today's discussion, it's interesting. So FN server are basically the server that will be running your function, right? So we'll have a bunch of FN server, and all of them will be fronted by an FN load balancer. And the goal of the load balancer is basically to try to do intelligent load balancing. Like, for example, if we have a function that is already running on a specific instance of an FN server, if we have a request for that function, they should go directly to that given FN server. And again, it's not something that you will expose in your code. What you will just do as a developer, you will just write your function, nothing else. So we have the server, we have the load balancer. Given that we are using containers, we are using Docker, we also need to have container registry. It can be a public one or a private one, it doesn't really matter. And then, so that's basically a very high-level overview of the architecture. What we also have, we have FDKs. FDKs stand for Function Development Kit. It's basically a kit that you can use to more easily write function. So we have a bunch, well, we have a few of them. Obviously, we have a Java FDK. I will show you some of the capability of the Java FDK. And something which is quite key, and it's also one of the differentiators that FN has, is FN Flow. So I will come back to FN Flow a little bit later on. So let's see how it works. So what I have running on my machine, I have Docker with FN running. So if we look at what we have, so we have an FN server running here, and we also have a flow service running here. I will explain what flow is later, but so let's create some example. Let's call it God, that's funny. So what I will first do, I will write a very simple function. And I will write that function in Go. Let's see, that's a little bit small. Using a French keyboard is not really... okay. Package, main, import, FMT. So that's a simple function that will basically FMT that will just say hello lava1. Okay. So oops, sorry. So you see, this is pure Go code. There's nothing specific to FN. So what I will do here, I will FN run. Oops, sorry, I forgot something. I first need to do an FN init. So you see, it found a Go function, so it assumed that it's Go runtime that needs to be used. And if we look at what has been created, basically it's just one YAML file. And if we look at that YAML file, there's not a lot in there. So that's the version of the function, then the runtime to use. Obviously, we want to use the Go runtime, and that's the entry point of our function. So now what we can do, we can run that function. And you see that when I do an FN run, well, if you know Docker a little bit, you will basically see that we are using Docker. So what is being done here is that we are basically creating a Docker image of our function. So if you look, so our Docker image has been created. So now you see that, well, that's, given that we have run our function, that's the result of our function. So this is basically how it works. Now I will remove that function, and I will do it a little bit differently. So I still want to do an init, but this time I will specify the runtime that I want to use. So I still want to use the Go runtime. Now if we look at our, so what has been created, so we still have the function that was already there. We still have the YAML file, nothing new. But what we now have, we also have a test file. So, oops. Thanks. So basically, out of the box, FN also provides the ability to easily unit test your function. So that means that if I run this function, yeah, maybe I need to show you the code of that function because it's basically an hello world, a generic hello world that has been, sorry. Let's see. Yep, code func.go. It's a little bit different, but it's, so it's a little, well, it's not very much more advanced, but basically it takes some incoming JSON payload and it just display that, right? So it's an hello world again. So if I run it, so given that my code has been changed, obviously my image needs to be rebuilt. And you see that the default output of the function is basically this. So that means that I can also provide some input, but for that I need to create the JSON input, and the JSON input should be, let's see, name. So I will create some fake input in the form of some JSON payload. So name, lava1, okay. And now if I pass that input, so yeps, if I pass that input to my function, so fn run, if it works, you see that now the input has been used. So hello lava1. What I can do, I can test my function. So fn test, first test passed, second test passed. So FN provides the ability to easily bootstrap a function, but it also provides the ability to easily test a function. So what I've done until now, I've just deployed my function, well, I've just run my function in a Docker container. Obviously, at the end of the day, I want to run my function on a FaaS platform. So for that, I need to deploy my function. So to deploy a function, I first need to create what we call an app. An app is basically a grouping of a function. And for that, I need to use, I never remember which command it is. Yes. So fn apps, oops, that was my fit. Fn apps create, and I will create a function that is, an app that is called lie, for example. So now I have an apps. I have two, in fact. So now I can deploy my function in my app. So let's deploy it. So I need to specify the app name, which is lie. And I need to specify that I don't want to push my image to a registry. So now if I look at routes, so basically a route is basically used to reach, the app name. A route is used to reach a function running on a platform. So I can either reach it using curl, or I can also invoke it directly using the fn CLI. So fn call. So I want to use, fn call. I need to specify the app, which is lie, and then the route within that app, which is god and hello world. So use, for example, if I pass my JSON payload, obviously it should still work. But this time it's invoked on the FN server directly. Anyone knows why FN is not recognized? It took me time to figure that. I'm typing too fast and it's not a space here. Yeah, but it took me time to figure that out. So you see now my function is running on my FN server and my payload is being passed. So what we've seen so far, so we are using Go we are using FN CLI to init to bootstrap basically a function. We can test it. We can run it directly on a Docker container, and we can also deploy it on a FaaS platform. In this case, I'm just using FN server that is running locally on my machine. So let's go back to the slides. And obviously, we have a very good Java support. In fact, if you look today, I think that it's fair to say that writing function in Java is probably, well, I would say that Java is the most easiest solution to write function on top of FN today. But I'm biased. So we'll use Java, right? So let's create a Java function. So FN init, and let's call that Java function Duke, and we want to use the Java runtime. It's there. So if we look what we have here, we have a few files which has been created. So we still have the YAML file. We can look at that YAML file. So that's the version of the function. We want to use the runtime Java. That's, well, I will discuss about those one later. But basically, we could just have those two things, and let's see, and this one, and that would be enough. So basically, the command is basically the entry of my Java function. What we also have, we have some source file that has been created. So we have two files which has been created. So we have a very the skeleton of a Java function which has been created, and we also have a JUnit test which has been created for that function. And not only that, we also have a POM. So it's a plain old POM, Maven POM file that has been created for our function. So I will switch to NetBeans, which has just crashed. So given that we have a POM file, it's really a Java project, so I can open that project. Let's see, where is it? Lie. And it's indeed, well, you can't really see, but it's really a Maven project. So I will look if I need to change. Okay, is it? So let's see. Yep. So this is the default function which has been created. So you see that it's really a simple Java class. So we don't extend anything, we don't implement anything. It's a simple class with one method. And it also happens that if you look at the YAML file, so this is the class, and this is the method, right? So we also have a JUnit test which has been created for us. So that means that we can test our function directly from, I mean, like we would do with any Java project. So if I go here, test file. So my image needs to be built, and it fails. It fails. Yeah, I know why it fails. My NetBeans is not configured to use a Java 9, and out of the box, FN is using Java 9, so I need to stick to Java 8 at this stage. So I just update my POM file, and now I can test my function again, and hopefully it should go green, and it goes green, right? So it's really JUnit. Nothing really fancy here, but as a Java developer, it's important that we can keep using our tool. So I will now get rid of the test. RM source test. So let's see, what can we do here? So let's look at the Java function. So it's pure Java code. So that means that we can, for example, use Maven to import some dependency. So dependency. Which one? Artifact ID and Jodamoni would be a good one. Version. So until now, I haven't done anything specific to FN. It's pure Java programming. So now that we have JodaTime imported, we should be able to do something like it's big money. It's, yeah. Let's see, for example, +1. So this is pure Java code. So hello lava1, you just 1 plus m. So now I can run this Java function, which is using an external dependency that I'm importing through Maven. You see that here, basically, to build the image, we are using Maven. But again, it's not some. Well, it's something that is handled automatically for us. You see that we got all the dependency, and if everything goes well, so it's a bit slow this time because we have to rebuild the container image, and only then we can run the container image. And you see that, hello world, you've just won 10 euro. So this is using big money from Joe data. So we've seen that we can use JUnit. We've seen that we can basically keep using our existing tool, our existing library. And something else that is also provided by the Java FDK is type coercion. So basically the ability to keep using, well, because if you look here, basically what we get as an input for our function is a string, which is not necessarily very useful, right? So what I can do something like that. So I can create basically a bin. So a person, let's say it has a last name, it has a first name, right? So I need to constructor. So let's see, I need a constructor. I need getters. And I'm done. So very simple Java object, a person with a name and a last name. So now what I can do, so the input of my function is a string, but that means that now, given that I have that, I can change its type to a person. So this is what I am expecting to get as an input for my function. Obviously this guy will not run because we've changed the type, and here what we need to do, input, we need to use the Java object, and let's say get first name. We can get rid of that. So what we have done, we've basically changed the type, the input type of our Java function. Again, this is pure Java. There's nothing, we don't extend or implement anything. This is pure and plain old Java code. So if we run the function, so our image needs to be rebuilt. It works. And now it will be run and it fails. Why? Because my function is expecting to have a person type, and what I'm passing, I'm not even passing something. So I need to provide that that person type, and for that we are basically using JSON. So I need to pass it some JSON payload that represent a person type, and a person has a last name and a first name. So this is my incoming payload. Now I can pass that to my Java function. So it still fails. Why it fails? Oh yeah, I know why. I also need a default constructor. So given that I have added a default constructor, now when I run it, obviously my image will have to be rebuilt. So it has been built, it has been run, and you see that what the output of the function is now different. So it's hello and my first name instead of all the incoming payload. So FN provide through the FDK type coercion. Obviously it works with the input, but also with the output. So I can say that instead of producing some string type, here I can produce a person object. Well, I will just put it like that, so I will not, I don't have any setters. No, I don't have any setters, so doesn't matter. So I will just take the input and produce, well, send it that as output. So if I run it again, you see, we should see that the output should now be a JSON object. And it's indeed what we have here. So this is the kind of capability that are provided by the Java FDK. So testing, but testing the Java way, so meaning we are using JUnit, type coercion, so we can work more easily with Java type. You have the ability to customize the how the conversion is done. So under the hood, we are using JSON, and you have the ability to customize that. Also, the FDK it's provide basically you the ability to keep using your existing tool. So what we just provide is a POM XML, and that's it. So you can keep using your traditional Java tool. So this is a very short overview of the Java FDK. But obviously not everybody is using Java. So FN has been developed in Go, so I've shown you that we can also write function in Go. We plan to, in fact, we already have an early prototype of an FDK for Go. We also plan to have an FDK, so a function development kit for Python. And basically, you have the ability to bring any language, because at the end of the day, we are using containers. So you can use any language. The thing is that obviously you need to provide the capability to for that given language, and that's something that I have done like 2 weeks ago. So to try to understand how it works, I've decided to add Kotlin support to FN. So now, well, so this PR has not yet been merged, but hopefully very soon you should be able to do something like that. So let's say, so we want to create a function that is called cut, and this time we want to use Kotlin as the runtime. So if we look at what we have here in the cut function file, we again have a YAML file that describes our function. So the runtime to use is Kotlin indeed. The build image, that's basically the image that will be used to build the image that will be run. So the run image is the one that will be used to execute our function. So for Kotlin, I had to basically provide a specific Docker image for that. And the rest is pretty standard. So if we look at the Kotlin source, so this is a default function that you get. It's again a very basic function, but we can run it obviously. So fn run, and it doesn't work. Why? Because my function is expecting to have some type of object. Let's see, it expects to have an input name. So I need to specify that name. Lava one. More. So I'm passing my input to my function, and you see that what we have here is indeed hello lava1. And what we have used as a runtime, this time it's a Kotlin function. And I think that we can see that here I'm using Kotlin C to compile my function and produce a jar. So adding support for Kotlin is easy, because basically I only have to focus on the build function, and for the runtime I'm just using a standard Java container image. We can also test our Kotlin function. So it has to test by default, and both tests passed. So I mean, what I mean by that is that adding support for a language that is not supported by Project FN is something that is pretty trivial and can be easily done. So basically, you have the ability to do that by yourself. So, moving on. So FN project is not just Java. Something which is quite important about function is that function should be stateless. So you should not hold any state in your function. So functions are basically, will have an ephemeral instantiation, so they will be instantiate when they will be invoked, and they will die like not even 1 second later when they are done. So you shouldn't hold any state in your function. But at the end of the day, we still need to hold some state. So that's something that needs to be handled outside of the function. You can use Redis, you can use Kafka, and so on. The thing that is key, don't hold the state in your function. Having said that, there are some times when you have to, when you want to have some kind of state concept, is basically when you are composing function. So as I said earlier, a function basically performs one job well, and that's it. But it might be useful to compose multiple functions to provide some more advanced capability. Today there are different solutions to do that, using graphical tools, using configuration file, and so on. In FN, we are using a different approach. Given that FN is very much developer focused, we think that we need to provide what developers knows best. And what developers knows best is basically code. So basically, the way you will compose your function, if you are a Java developer, we will provide you a Java API to do that. So FN Flow basically provides this ability of composing multiple functions. It's very similar in spirit as the completion stage API. So we are in Java 8, we have this completion stage API that basically allows you to define an execution pipeline of multiple asynchronous steps. And the execution of one step, one stage, might trigger the execution of another steps. So this is basically exactly the same concept, except that this time we're not talking about task or stage running within the VM, but we're talking about function running in a Docker container. So we're basically talking about execution outside of the process that is invoking that function. So to illustrate that, I have a very simple scenario running on my machine. It's the typical flight booking, travel booking scenario. So we are using multiple service providers. So we have a provider to book the flight, we have a provider to book an hotel, we have a provider to book a rental car, and we also have a services that is used to send confirmation. It happened that all those providers and all those services are using different technology. On my slide, they are using Java, Ruby, JavaScript, and Python. It's not exactly true. On my laptop, I'm using Java, Ruby, JavaScript, and JavaScript. But it doesn't matter, because we are just consuming those functions. We don't really need to know what's behind that. What we want to focus on is on the trip booking function. So basically, the trip booking function is the guy that will orchestrate the different services to book a trip. And booking a trip means I want to book a flight, then I want to book an hotel, and then I want to book a car. And once I'm done, I want to send an email. So for that, we'll use the Flow API. So let's get rid of that. So I have the travel services running here, and sorry, the travel function. And if we look at the function itself, it's basically empty. So there is just one helper that is here. So this is my my FN function, my trip FN function that will use the Flow API. So f equal flows, current flow. So I'm creating a flow, and in this example, I will do the most basic flow, 42. So I'm creating basically a flow that is already has a value. So this is the most basic form, and now what I can do, I can run that function. So for trip. So this is my travel services, and you see that I have multiple services. So the one that I want to use is this one, the trip, which is the Java one that needs to do the orchestration between the multiple services. Let's see. So let's run this trip function. and it failed again because I haven't provided any input to my function. And I think I have some input here. If I run. And it ran again. Why? Let's see my input. My input looks okay. Oops. That sucks. So the thing is that, so the issue here is that I don't have my flow services, because obviously, given that we're talking out of the process execution, we need to have an orchestration. So that's the flow services that is doing that. So let's see. I think it should be somewhere here. Scripts. No, it's not here. I know where it is. I need to have the URI of my flow. Yep. Okay. So let's see. It should be start. Now I need to be in the right directory. Yeah, something I forgot to do. I need to deploy my function simply. Deploy, so for that, so I need to deploy my function. So I need to specify the app, which is the travel app, and my function is the local one. So, and again, I need to say that I want to use an external registry. So let's try to invoke that guy. So now I can, oh sorry, I'll deploy it again. Fn call. Sorry. So I need to pass the payload. Fn call. The application is the travel application, and we want to use the trip function in that application. And well, it doesn't do anything. That's well, that's quite normal because we haven't asked what we're creating. We're creating basically an empty flow. So the thing is that if I run it again, I should see that indeed something has happened, but not necessarily something very useful. So let's change that flow with a little bit more advanced flow. So basically what we're doing here, we are creating some flow features, so 3 of them. One is invoking the travel booking function, another one is booking an hotel, sorry, this one is booking a flight, this one is booking an hotel, and this one is booking a car. And you see, I mean, if you have been using the completion stage API, it's something that is very similar. So we have one flow, then once we have the result, we pass the result to the second function invocation, and so on and so on. So let's save that function. And now let's deploy it again. So okay, so now we can invoke it. Oops, sorry. Yep. And well, we see that something has happened. Well, let's move here. So I will invoke the function again, and we'll see here what I have, some kind of fake UI that see what is going on. So you see we've booked an hotel, we've booked a car, and then we've booked a flight. Now we can also look at the execution of the flow here. So it's basically a different view. So we are booking an hotel, now we are booking a car, and we are booking a flight, and we are invoking the travel services, sorry, the email services to send the result. And you see that the main execution took like 6 seconds. Now, the issue here is that, for example, if I inject some error, like, let's say that now every time I will invoke my hotel booking services, it will just fail. So let's try. Well, we see that indeed it fails. But if we look at the execution here, so we try to book an hotel, we try to book a flight, and so on. You see that we haven't sent a mail. Why? Because we are not dealing with error. So to deal with error, I will basically need to change this guy to something like this. So basically, this is again the same invocation, but this time, like we have in the completion stage API, we also have the ability to deal with error. So if something goes wrong, I will, for example, if I can book a car here, I need to make sure that I invoke the services to cancel the car booking, just in case. Or if I was able to book a car but not an hotel, I need to make sure that I cancel the whole trip. So I need to basically roll back the complete transaction. And once I'm done, I will not send a confirmation mail, but I will just send a mail that says, sorry, something went wrong with your reservation. So let's deploy the function again. Let's clear this. Let's clear this. And so now the function has been, the updated function has been developed, so has been deployed. So let's invoke it. So we have an error here, and what we should see here is that indeed we've cancelled the flight, we've cancelled the hotel, we didn't cancel the car. I'm not sure why. Yeah, something went wrong here. Not sure what was going on. And if we look at the execution here, so we can't book the hotel, so we cancel the flight, we cancel the hotel, and something is wrong with my car booking. But and we also see that here, given that we have an issue, we send a mail, but it's a fail mail. So it's a notification saying, telling the user that something went wrong with the booking. So that is basically the idea of the Flow API. So it's this API that allows you to easily compose multiple functions. So basically, you have the ability to do orchestration between multiple functions using an API. So you don't have to use a graphical tool like some others provide. It's something that is very, well, it's not intuitive to use, especially when you have to deal with error or retry, those kind of things. And the more function you add in your flow, the more complex it gets. Here you basically have an API to deal with that. So FN project also provide capabilities to do monitoring and management, something that is important if you are running the platform. I mean, at the end of the day, if you are just a consumer, you just need to have metrics and statistics. You don't necessarily to see what's running under the hood. But given that everything is open source, you have the ability to use FN locally on your machine. You can also use FN on premises if you want to do so, or you can, at some point in time, use our service offering if you want to. So, as a recap, FN project is a container native, so you saw that we are using under the hood Docker containers. Given that we are using Docker containers, it's cloud agnostic, so obviously it run well and very well on Oracle Cloud. But given that everything is open source, anybody can take FN and deploy it. It's polyglot, so we saw that we are supporting different language. So we have a Java FDK, we have a Go FDK, we're planning to add a Python FDK. But then you also see that you can easily add other language if you want to do so. So in terms of building blocks, we have FN server. We can have a bunch of them. That's what I have running on my machine. I have one FN server. If you are going into production, you will need to front that with the load balancer to do the routing, the intelligent routing to the different FN servers. We have multiple FDKs, and clearly the FN flow is really one of the one of the differentiators that we have versus other serverless open source solution. Today we have FN flow for Java, but we also have a prototype for Go, and more might come. I think there will be one for Python. Obviously, we have very good Java support. So Java is a first-class citizen, but it's not just Java. It's very much developer-focused. So you see that you can easily bootstrap your code. You can directly test your function. You can deploy your function locally on a Docker running on your machine. You can then deploy it on a FN server running on your machine, running on premises, and also at the end of the day, you can also deploy it on a FaaS platform. And then there are a bunch of other things that I will not really discuss today. Like, for example, we provide an Helm charts to deploy FN on top of Kubernetes. We have support on the Java side for JAX-RS. So Java developers like to use JAX-RS, so that's something that we want to provide them. We have some initial support for Spring Cloud Function. We also have, for example, Hot Function. I can quickly show you that. So Hot Function is basically this. So let's see. Let's go back. Let's see. So we have a Kotlin function here. No. So in JSON, no, I need to first deploy my function. So deploy. The app is lie, and I'm deploying this function. I'm deploying this function. So if I invoke it now, so I need to pass it some payload. FN call app, no, lie, and the function name is cut, I think. Yeah. But what I want to do here, I want to look at what it takes. So you see that the function has been executed, so hello lava1. It took like 1 second, which is quite a lot. So if I invoke it a second time, it took nearly 1.5 seconds, which is quite a lot. Now if I use the hot function capabilities, for that I just need to specify that the format to use is HTTP. So I need to make sure I save my file, deploy. So I invoked my function again, and it took 1 second. And you see that the second time I'm invoking my function, well, it took way more. So we basically went from 1 second to 81 milliseconds. So why? Because the first time we have to bootstrap the container. So we basically need to run the container that will run the function. But if we're using hot function, basically we have the ability to keep that container running to serve other function. So that means that the next time someone is coming, the container is there ready to serve the function. And that's why we are seeing here. So basically, by default, my container will stay up to 30 seconds to be ready to serve other function. So that's what we mean by hot function, having the ability to keep container running to serve function. So, if you want to learn more about FN project, and if you just want to one URL, just go to the GitHub repo. Everything is there, documentation, tutorials, the different FDK, the source code, obviously. So that's really the one the place I would encourage you to visit. And then you can also hang out in the FN Slack channel. All the developers are there and ready to answer that. Any question that you might have. Yes?
Yeah, you're saying the same thing that I'm saying.
So you mentioned you have support for Kubernetes in the pipeline. How pluggable is that back end? How open is it to extension for other container solutions or management frameworks? I mean, we at Twitter use Mesos, which is kind of like the NetBeans of distributed container systems. So if we wanted to implement something on top of this, because I will just say real quickly that UI and CLI experience looks really great for the stateless function-oriented apps.
So clearly, as Oracle, we're focusing on Kubernetes because that's what we're going to use. If you were asking that question like 2 years ago, we were using Mesos, but we've decided that strategically it makes more sense to use Kubernetes. So that's why we're focusing on Kubernetes. So I don't think that we will provide the ability to, well, not the ability, but how you can easily deploy FN on top of Mesos. It's not something that we would that we are going to do, I think.
Sure, I wouldn't expect Oracle necessarily to drive that, but I mean, how tied or how closely coupled is, let's say, the Docker container format to this? How tightly coupled is the actual, like, you have SDKs for other languages that makes it easy on the front end. How easy is it to adapt this to other distributed container management solutions and or other container formats?
It's quite tied to Docker, I would say. So
okay. Cool.
I mean, Docker, I wouldn't say that Docker is our abstraction layer, but everything is based on Docker. So above that, you are free to do what you want.
Cool. Thank you.
Other questions?
I know, well, everything is open source, so I mean, if you want.
Right, of course. Questions? No? Comments? I have to correct David. You're supposed to go to the Twitter URL, actually, not the GitHub one. But
yeah, we do have one. It's
yeah, I know,
at
but
the
it's at the
bottom.
very bottom.
Yeah, but that's the one people see.
Ah, okay, yeah, right. So foods here, I don't know, not completely, I think. I don't